So now welcome in most amazing topic is edge computing in the cloud. So introduction is edge computing is one of the most exciting frontier in the cloud technology. Traditionally, cloud computing has relied on a centralized data center where massive amount of data are processed and stored. While this model works well for many applications, it introduces latency and bandwidth challenges with dealing with a real-time system such as autonomous vehicles, smart cities, or healthcare monitoring. Edge computing solves this problem by moving our computation closer to the source of data at the edge of the network. Instead of sending all the data to distant cloud services, each device such as a router, gateways, or local servers process information locally on summarizes or critical results are sent to the cloud. This hybrid model combines the speed of local processing with the power of centralized cloud analytics. Evolution of cloud compute model: centralized computing, client-server model, cloud computing, edge computing. Centralized computing is what early system relied on mainframe where all processing occurred in one location. Client-server model is introduced distributed computing, but server however still centralized. Cloud computing is what enabled elastic scaling and global access, but data is still traveled long distance. Edge computing brings computation closer to device, reduce latency, and enabling real-time responses. The architecture of edge computing is edge device. These include IoT sensors, smartphones, cameras, and industrial machines. They generate data continuously. Edge nodes, router, gateways, or local server act as an intermediate processing unit. They analyze data locally before sending it to the cloud. Cloud integration. Cloud integration is the cloud remains essential for large-scale analytics, storage, and machine learning. Each device sends summarized data to the cloud for deeper insights. Hybrid model. The most system use hybrid approach, edge computing for real-time tasks and cloud computing for long-term analysis. Advantage of edge computing is reduced latency, real-time decision making, bandwidth saving, reliability. Challenges is security risk, hardware limitations, synchronization, management complexity. And the real-world applications is autonomous vehicle, smart cities, healthcare, industrial IoT. Or case studies is one is Tesla, so we discuss this. Tesla's autonomous driving system relies heavily on edge computing, cares the processes sensor data locally to navigate safely, while the cloud aggregates data for improving algorithms. And next is healthcare variables. Device like smartphone use edge computing to monitor heart rate and detect irregularities. Instead, the cloud stores data for doctor to review data. Integration is 5G network will enhance edge computing by providing ultra low latency and high bandwidth. This will enable application with remote surgery and immersive AR and VR. AI of the edge, expansion in smart homes like edge computing will power smart appliances, security system, and energy management in home. Cloud provides offering edge zones just like AWS, Azure, and Google Cloud are deploying edge zones, mini data centers closer to the user to reduce latency further. So conclusion is edge computing represent paradigm shift in the cloud technology by processing data closer to the source. It reduces latency, saves bandwidth, and enables real-time decision making. While challenges such as security synchronization remain, advancement in 5G, AI, and edge zones are rapidly addressing them. From autonomous vehicle to smart cities, healthcare to industrial IoT, edge computing is shaping the future of digital systems. It complements cloud computing rather than replacing it, creating a hybrid model that balances speed and power. As the technology evolves, edge computing will become a cornerstone of modern application, driving innovation across industry. This is the edge computing we discussed. We discussed already. So this is an amazing topic. Thank you for watching.